Hello everyone, welcome back, and yeah, let's continue our discussion about partial fraction decomposition. Okay, so what is partial fraction decomposition again? We have a big fraction like this, we have a rational function, okay, and what we want to do is we want to decompose it, we want to tear it apart, or we want to write it as a combination of several simple fractions. So if I do partial fraction decomposition for this specific fraction, what I get is 4 over 5x minus 15 plus 1 over 5x plus 10. Okay, don't worry how I got it, it's just I am trying to show you what is partial fraction decomposition. See, the fractions in the right hand side are much simpler fractions than the left hand side. Okay, perfect. Now where do we start? Well, the partial fraction decomposition is a little bit complicated because it contains different types of strategies for different types of fractions. Well, we have different types of fractions, so that's the point here. Look at these two fractions, 3 over 4 versus 5 over 4. What is the difference here? Well, in the first fraction, numerator is smaller than denominator, right? But in the second fraction, numerator is larger than denominator. But these are just numbers. Now, but that's that's two kinds of fractions, right? Now, in partial fraction decomposition, we deal with rational functions, meaning we have a polynomial over polynomial. So how do you compare which polynomial is bigger than the other? You know what I mean? So how do you compare that in a polynomial? Well, we compare that using the degree of the polynomial. So for example, in this fraction, which one is bigger, x plus 1 or x square minus x minus 6? Well, we can compare them using the degree. So we have two cases depending on the degrees of numerator and denominator. Okay, so what is degree again? So let's quickly recall. Degree of a polynomial means the highest power of the variable that you have in the polynomial. So for example, in the denominator, the highest power is 2x square, 2, and in the numerator, x to the power 1 is the highest power, x to the power 1, that term. So it's in the numerator degree 1 polynomial, in the denominator degree 2 polynomial. So depending on the degrees, we have two cases in rational functions. Case 1 where denominator is larger than numerator, case 2 where denominator is smaller than numerator. So let's see. So in case 1, look at this case. So in the numerator we have degree 1 polynomial. In the denominator, x square degree 2 polynomial. Here in the second example, degree 1 polynomial in the numerator, x to the power 1, degree 3 polynomial in the denominator, right? Degree 2 polynomial in the numerator, degree 3 polynomial in the denominator, right? So as you can see, in all these three examples, denominator is larger than numerator in terms of degree. In case 2, look at here, degree of the numerator is 3, degree of the denominator is 2, so numerator is larger. Degree of the numerator is 4 here, degree of the denominator here is 3, so again numerator is large. So that's case 2. So we treat these two cases differently when we use partial fraction decomposition. Okay, so starting from this video, I first will address case 1. I will teach you how to do case 1. Alright, so let's go to case 1. Well, we have a perfect example. Let's pretend that we don't have this answer. And okay, so this is case 1, right? Denominator is larger than numerator. The very first thing you do here is you factor the denominator as much as possible. So write it down. So that's the very first thing you do in partial fraction decomposition. Factor the denominator as much as possible. So let's factor it. X plus 1, x minus 3, x plus 2 if I factor denominator. Okay, it's a quadratic polynomial. I did that fast. Okay, alright, if you don't know how to do the, pause that and review your factoring of quadratic polynomials. Okay, perfect. Now here's the thing, case 1, within case 1 we have several other cases. Okay, I know it sounds hard. Now case 1 means again denominator degree is larger than numerator. Now within case 1, depending on the factors you get, you have several cases. That means you can get several types of factors. Well, what do I mean? Okay, let me show you. So we are still in case 1. So case 1 can have 4 sub-cases. So these are 4 sub-cases. The first sub-case is distinct linear factors. So these all sub-cases have to do something with factors. Okay, so you get these cases after you factor the denominator. Distinct linear factors. What do I mean? Distinct linear factors means exactly what I got here. Distinct mean 2 different factors. So x minus 3 and x plus 2, 2 different things. Okay, so distinct there. Linear means the maximum power of each factor is 1. You only have x to the power 1 terms in every factor. So here x to the power 1, here x to the power 1. So this is distinct and linear. So this is distinct linear case. Okay, so let's write it down. So here we have, I can't remember what I had in the numerator, but this is an example of a distinct linear factor where you get distinct linear factors. Now then, what is non-distinct linear factors? Well, non-distinct factors, well, that means repeated factors. So let's think about repeated factors. Means a factor is repeated. So let me write an example here. X plus 1, how about x minus 4 square times x plus 2? So here x minus 4 square means the meaning of that square is what? X minus 4 times x minus 4, right? So once you factor your polynomial, if this is what you get, you have a repeated factor. X minus 4 is repeated twice. So that's a repeated factor. Okay, so that falls under repeated category. Irreducible factors. Now irreducible factors means your factors are not linear. That means power of the x term is greater than 1. So let me show you an example. X plus over 7, x square plus 1, x minus 3. Now look at this. X minus 3 is actually linear, but is x square plus 1 linear? No, it's not linear. The power of this factor is 2, right? So it's a quadratic polynomial, second degree polynomial. But then here's the thing. I said you that you have to factor your polynomial factor denominator as much as possible. But can we factor x square plus 1 furthermore? Can we tear it apart furthermore? No. Give it a try. You can't. You can factor x square minus 1, but you can't factor x square plus 1. Okay, if x is a real number, but that's a different discussion. Let's not go there. But simply you cannot factor x square plus 1 here. Okay, so we call it an irreducible factor. So think about the name. Irreducible means not reducible. You cannot reduce it down to linear factors furthermore. So this is irreducible case. Well, repeated and irreducible means like, so let's take the same example, x plus 7, x square plus 1 square. So this is irreducible. X square plus 1 is irreducible. You cannot factor it furthermore. And not only that, it's repeated twice. Okay, so 4 different cases: distinct linear, repeated, irreducible, repeated and irreducible. So we treat these cases differently. Okay, so I just first want you to show all the cases that we have within partial fraction decomposition. All right, so in the next video we will start with distinct linear case because it is the easiest case. So let's quickly summarize. Okay, let's try to quickly summarize what we learned in this video. So partial fraction decomposition, we have 2 types of rational function. One, denominator degree is larger than numerator. Next, denominator degree is smaller than numerator. Let's talk about case 1 for now. Case 1 means denominator is larger than numerator. Now the first thing you do is you take the denominator, you try to factor is as much as possible. Okay, and then once you factor them, you look at the factors you get and you identify which subcategory you belongs to. So you might get distinct linear factors. All the factors are different from each other, so distinct, and they are in each factor, in all the factors, the maximum power of x is 1, so linear factors. Or you might have repeated factors where one factor is repeated 2 times, 3 times, for example x minus 4 square or x minus 4 cube. So that's repeating factor. Irreducible factor means the power of the factor is larger than 1. Okay, and that term cannot be reduced down furthermore. You cannot factor that term furthermore. So that's irreducible. Repeated and irreducible means you get worse of the both cases. Okay. All right. So okay. In the next video, let's start with distinct linear factors. I'll see you there. Thank you very much. Bye bye.